Water uses and pollution. Water is arguably the most important physical resources, as it is the only one that is essential for human survival. We would die very quickly without it. Other physical resources can make life more comfortable, but water makes life possible. If you were shipwrecked on an island, a priority would be to find a fresh water fairly quickly. The thought of looking for other physical resources on the island, such as minerals for construction, fuel for warmth, or metals for tools, would come much later, if at all. Water is the most common substance on Earth's surface. It exists on land, in oceans, and in the atmosphere. Water may be pure or contain dissolved substances, particularly salt, in ocean water, some lakes, and deep underground. Water resources are usually fresh water with low content of dissolved suspended and biological substances. Although water is abundant on Earth, fresh water is much less. So being only few percent of total water, and in some places on Earth, it is very scarce. Water differs from most other resources, as it is a renewable resource, continuously driven around in a cycle by the energy of the sun and the Earth's gravity. For example, rain falling on land flows away to the sea, in rivers, and so is lost as fresh water resource. But rain will fall again, replenishing the rivers. The rainfall may be irregular or seasonal, so the renewability of water is not instantaneous, but has a delay of few days or even many years. In comparison with the time needed to form other resources, such as sand, gravel, coal, or petroleum, this time is very short, so water is regarded as renewable resources. Problems are caused by the presence of too little water or too much of water. The 1970s and early 1980s were a time of widespread drought in the Sahel zone of Africa and in the southern republics of the former USSR. Floods were particularly prevalent in 2000, with widespread flooding in Mozambique in Africa and in the UK. Water use and consumption. Water from different resources is withdrawn both for use and for consumption in diverse human activities. The term use refers to all human activities for which some of the withdrawn water is returned for reuse. In contrast, consumption means that the withdrawn water is non-recoverable. For example, evapotranspiration of water from plants is released into the atmosphere and is considered non-recoverable. The water content of living organisms ranges from 60% to 95%. Humans are about 60% water. To sustain health, humans should drink from 1.5 to 2.5 liters of water per person per day. In addition to drinking water, Americans use about 400 liters per person per day for cooking, washing, disposing of waste, and other personal uses. In contrast, 83 other countries report an average for personal use of water per person per day below 100 liters. Current U.S. freshwater withdrawals, including those for irrigation, total about 1,600 billion liters per day, or about 5,500 liters per person per day. Of this amount, about 80% comes from the surface water, and 20% is withdrawn from groundwater resources. Worldwide, the average withdrawal is 1,970 liters per person per day for all purposes. Approximately 70% of the water withdrawn worldwide is consumed and non-recoverable. Water can be used for direct and indirect purposes. Direct purposes include bathing, drinking, and cooking, while examples of indirect purposes are the use of water in processing wood to make paper and in producing steel. For automobiles, the bulk of the world's water use is for agriculture, industry, and electricity. The most common water uses include drinking and household needs, recreation, industry and commerce, agriculture, thermoelectricity, or energy. Water pollution. Water pollution occurs when harmful substances, often chemicals or microorganisms, contaminate a stream, river, lake, ocean, aquifer, or other bodies of water, degrading water quality and rendering it toxic to humans or the environment. Water is uniquely vulnerable to pollution. Known as universal solvent, water is able to dissolve more substances than any other liquid on Earth. It is the reason we have Kool-Aid and brilliant blue waterfalls. It's also why water is so easily polluted. Toxic substances from farms, towns, and factories readily dissolve into and mix with it, causing water pollution. Categories of water pollution. Groundwater pollution. When rainfall seeps deep in the earth, filling the cracks, crevices, and porous spaces of an aquifer, it becomes groundwater, one of our least visible but most important natural resources. Groundwater gets polluted when contaminants from pesticides and fertilizer to waste leach from the landfills and specific systems make their way into the aquifer, rendering it unsafe for human use. Ridding groundwater of contaminants can be difficult to impossible, as well as costly. Once polluted, an aquifer may be unusable for decades or even thousands of years. Groundwater can also spread contamination far from the original polluting source as it seeps into streams, lakes, and oceans. Surface water pollution. Covering about 70% of the Earth's surface, water is what fills our oceans, lakes, rivers, and all those other blue bits on the world map. Surface water from freshwater sources accounts for more than 60% of the water delivered to American homes, but a significant pool of water is in peril. According to the most recent surveys on national water quality from U.S. Environmental Protection Agency, nearly half of our rivers and streams and more than one-third of our lakes are polluted and unfit for swimming, fishing, and drinking. Nutrient pollution, which includes nitrates and phosphates, is leading type of contamination in these freshwater sources. Ocean water pollution. 80% of ocean pollution originates on land, whether along the coast or far inland. Contaminants such as chemicals, nutrients, and other heavy metals are carried from farms, factories, and cities by streams and rivers into our bays and estuaries. From there, they travel out to sea. Meanwhile, marine debris, particularly plastic, is blown in by wind or washed in via storm drains and sewers. Our seas are also sometimes spoiled by oil spill and leaks big and small, and are consistently soaking up carbon pollution from the air. Agricultural. Around the world, agriculture is the leading cause of water degradation. In the United States, agricultural pollution is the top source of contamination in rivers, streams, the second biggest sources in wetlands, and the third main source in lakes. Every time it rains, fertilizer, pesticides, and animal waste from farms and livestock operations wash nutrients and pathogens such as bacteria and viruses, into our waterways. Nutrient pollutions caused by excess nitrogen and phosphorus in water or air is the number one threat to the quality worldwide and can cause algal blooms and toxic soup of blue-green algae that can be harmful to people and wildlife. Sewage and wastewater. Used water is wastewater. It comes from our sinks, shower, and toilets, and from commercial, industrial, and agricultural activities. The term also includes storm water runoff, which occurs when rainfall carries road salts, oil grease, chemicals, and debris from impermeable surface into our waterways. More than 80% of the world's wastewater flows back into the environment without being treated or reused, according to the United Nations. In some least developed countries, the figure tops 95%. In the United States, wastewater treatment facilities process about 34 billion gallons of wastewater per day. These facilities reduce the amount of pollutants such as pathogens, phosphorus, and nitrogens in sewage, as well as heavy metals and toxic chemicals in industrial waste, before discharging the treated water back into the waterways. Oil pollution. Big spills may dominate headlines, but consumers account for the vast majority of oil pollution in our seas, including oil and gasoline that drips from millions of cars and trucks every day. Moreover, nearly half of the estimated 1 million tons of oil that makes its way to the marine environments each year comes not from tanker spills, but from land-based sources such as factories, farms, and cities. At sea, tanker spills account for about 10% of the oil waters around the world, while regular operations of the shipping industry through both legal and illegal discharges contribute about one-third. Oil is also naturally released from under the ocean floor through fractures known as seeps. Radioactive substances. Radioactive waste is any pollution that emits radiation beyond what is naturally released by the environment. It's generated by uranium mining, nuclear power plants, and the production and testing of military weapons, as well as the universities and hospitals that use radioactive materials for research and medicine. Radioactive waste can persist in the environment for thousands of years, making disposal a major challenge. Consider the decommissioned Hanford nuclear weapons production site in Washington, where the cleanup of 56 million gallons of radioactive waste is expected to cost more than $100 billion and last through 2060. Accidentally release or improperly dispose of contaminants threaten groundwater, surface water, and marine resources.